Hello everybody, how y'all doing? Hope everybody's having a great day. This is gonna be the first video of Programming Workshop 2, Midterm 2, and the first unit for Midterm 2 is gonna be command line arguments. Command line arguments are very simple. It's something you pass for the code in your terminal. It's command line arguments, literally. So let's say I compile this. I go g++ command arg.cpp -o command arg. Command arg. See, I compile it. Now I do command arg, and I want to give it some parameter. Let's say version 2.3. That's what I want to run. Let's say, right? Or I want to tell it run for 50 seconds, and it will run for 50 seconds. Whatever that you want to put without having to recompile. So usually when you want to run your program for, let's say, 50 seconds, you'd have to go here, change it to 50 seconds, recompile, rerun. But when you pass arguments, you could do that from the terminal without having to recompile the whole thing. Okay, so that's how you use command line arguments. Now, what you need to know in order for you to do command line arguments are pointers. You probably should already know this by the time it's midterm 2, but in case you don't, I'm going to go over it. In order for you to do pointers, you're going to have a stack like this, and this is going to call it the stack, right? The stack is memory. This is where your program is, okay? So this is going to be your program inside this box, all right? So here, let's say I'm going to go int. When you make a pointer, you have to tell it what it's going to point to. So if I want to point to an integer, a double, a character, you get the point. I spelled double wrong, I know, but you get the idea. So now we're going to make an integer pointer. Okay, we decided what we're going to point to. We're going to point to integers. How do you specify a pointer? If I do A, this is a variable. Or if I do G or B, is variables. When I put an asterisk, this says I'm a pointer now. I'm going to name it PTR. You could name it also anything. It's the same thing. But PTR for pointer, it makes sense for the reader. It just makes sense, okay? The other thing is we're going to make A. But actually, before we make A, let's say you just make a pointer. Where does it point? Where it's going to point to is somewhere useless in the memory. Somewhere that is dead. All right? So you see right now, we have it here, and we have a line. Okay? Let's say this memory is 0xF1E9. Okay? Let's just say that's our memory. This is going to be your pointer. So this is going to be int PTR, right? Which is pointer. This, when it's made, is going to point somewhere to this address, let's say. And this, let's say, is 0xF1E56 or 52. Okay? That's our pointer right there. So what's in here? This is called a garbage number. You're going to find out that when you point to a random place in memory, you're going to find just some number. Like, I don't even know. It's just random ass number. And you see, when we're going to test it, I'm going to take the pointer. I'm going to dereference it. What does that mean? Dereferencing, you tell the pointer, go to the address you're pointing to. So here, let me delete this. And I'm telling it, so right now it's pointing to the address. It's not pointing to the box. It's pointing to the address. When you give it this access sign, you tell it, go to the address and tell me what's in there. You see now when I save this and I compile, I get garbage number, random ass number. Look, I'm going to run it again. Random number. Run it again. Random number. See the point? So when I remove this, what does it give me? What do you guys think? Look, I run it. Give me the address. What address is this? This is the address where it's pointing to. All right. Now, what if I do ampersand? This will give me the address of where the pointer is stored. So it's going to give me the address of this. The pointer itself. Let's see, I save this, compile. That is the address of the pointer. Now you're going to ask, well, how do I know the address it's holding and the address of the pointer are not the same? Well, what's the difference between this and this? How do I know if it's true or like you're just making this bullshit up? Watch this. I'm going to make a variable a. Let's say a equals 5. Right? And what I'm going to tell the pointer, can you point to a? Okay. But this, when I say a, so you see when you do here, std out, and you do a, what does it print you? This prints you the value a. So right now, I didn't give it an address. I gave it an integer, a, aka 5. The pointer's like, oh, there's a problem. You see? Type int extras. This is an int. This is a number. I want an address. So, like we said, you give an %, that gives you the address. Now, to test what we said earlier, how do you know it's holding two different addresses? So you see when I do this, and I tell it this is the address. So here, I say print me the address of A, which is what I'm passing. And here, I'm telling it print me the address you're holding. So you see when I run this, these are actually going to be, where's my arrow? Okay. You see this is going to be the same address because it's holding the same integer, same address. But when I do this, this is the address of the pointer itself. And you see two different things. And then you're like, oh, these are similar. How come these are similar? So you see here, if we're using the numbers that the computer gave us, removing all these, let's remove this. This pointer is stored at 0, 0, x 5, ff, e 898, right? Now the pointer under it is stored at 0, x 5, fe 94. Look, why is this 4 bytes apart? Right? The reason is integer takes 4 bits. And so there's 4 differences. So this takes 1, 2, 3, 4 bits. And this also takes 4 bits, which is 1, 2, 3, 4 bits. And the next slot, if this was an int, another variable, this will also take 4 bits. Okay? And that is pointers. That's all you need to know for now. And we're going to get more advanced in a bit.